तो चलो बच्चों, आज हम स्टार्ट करेंगे सीबीएसई क्लास 8 का रैशनल नंबर। रैशनल नंबर ये नाम आया कहां से? देखो, रैशनल नंबर अगर हम देखेंगे तो रियल नंबर, इसका मतलब अब तक जो भी नंबर्स आपने सीखे हैं वो सारे नंबर रियल नंबर आर ऑल द नंबर दैट यू हैव लर्नड टिल नाउ। ओके, रियल नंबर we can further classify into two different types, that is rational number and irrational number. Okay, rational numbers can be defined by two different types. One is decimal rational numbers. Decimal rational numbers have two types, decimals and fractions. Okay, actually fractions means positive or negative fractions are called as rational numbers. Okay, positive or negative fractions. Okay, we have learned that fractions are only positive. So fraction has the definition that p by q, fraction can be denoted in the form of p by q, where p and q are positive integers, or you can say whole numbers. Okay, where q is not equal to 0. But in rational number the definition changes. Okay, let's not call it as fraction form, let us call it as p by q form. Okay, so now decimal, if I am talking about decimal and I want the rational number, the decimal number I want to be the rational number, then it must be terminating rational number, terminating rational number, terminating decimal, or it must be non-terminating recurring decimal. Okay, see, I am teaching you at a depth. Okay, I am teaching you at a depth, so I am going to make you understand what is the meaning of terminating decimal as well as non-terminating recurring decimal. Okay, let us take some space here and find out what is terminating decimal. So terminating decimal means 2.3, 0.3, 0.233, 36.321163. Okay, there can be n number of digits after the decimal points, but they must be countable. There must be some definite number of countable digits after the decimals. Those are called as terminating decimals. Okay, non-terminating decimals means non-terminating decimals. For example, I am taking one example, for example 2.333 and so on. Okay, this is non-terminating. Okay, this 3 and 3 indefinitely it occurs again and again and again and again, so it is called as non-terminating recurring decimal. It is repeating, 3 it is repeating, so we can write it as 2.3 and we can add bar, or we can write it like this. Okay, next I can also write it like this, 2.123, 123, 123 and so on. So I can terminate it as 2.123 bar. Are there some other type of decimals? Yes, there are some other types of decimals which are non-terminating but non-recurring. See, these are recurring, 3, 3, 3, 3, 3, 3, it is recurring. 1, 2, 3, 1, 2, 3, 1, 2, 3, it is recurring. But in some decimals, number do not have a fixed pattern. So it is non-terminating, recurring. But there are also some numbers that are non-terminating, non-recurring. Okay, they do not have a fixed pattern. For example, if I write 2.3436, 3738, 3912147 8 and so on. See, you can't see any pattern in them. Okay, you can't see any pattern in them, and the division of these decimals will not stop eventually. Okay, division of these decimals will give you some recurring numbers after decimal point, but this number will never give you a fixed recurring number. So these numbers are irrational numbers. So these numbers are irrational numbers, and otherwise terminating decimals and non-terminating recurring decimals, non-terminating recurring decimal come under rational number. Okay, so under irrational number I am going to write non-terminating, non-recurring decimals. But if I want to write in the form of P by Q, then rational number can also be represented in the form of P by Q, where P and Q both belongs to any integer. It can be 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. So P and Q belongs to any integer. But here Q never belongs to 0. This is the simple definition of rational numbers. An irrational number, there it can never be written in the form of P by Q, where P and Q belongs to integer. So irrational number do not have any P by Q form. So you can write rational number as 2.3, 3.42 bar, 3.043 bar, like this. Or you can write rational number as 2 by 3, 3 1 by 4, 17 by 6, minus 2 by 3, 0, 1. These are all rational numbers. But irrational numbers are root 2, root 5, root 7, and so on. Yeah, the addition of two irrational number is also irrational. So root 2 plus root 3 is also irrational. Addition of rational and irrational is also irrational. So these are also irrational numbers. Pi. Do you know what is the value of pi? You think the value of pi is 22 by 7 or 3.1416. No. The value of pi is not 3.1416 or 22 by 7. It is just an approximate value that we take for calculations. But pi is actually irrational number. After decimal point, its number do not repeat themselves and they are indefinitely countless after the decimal point. Also e raised to the power 2x exponential. Here e, this is also irrational number. There are many irrational numbers that we take account as a constant. Okay, so these are all irrational numbers. These are all rational numbers. Okay, there are many more properties of rational and irrational number that we are going to see in class 9th and class 10th. But till class 8, you must have this knowledge of rational and irrational number. Okay, now let us see just about the rational number. Now I am interested into rational number. Rational number means terminating decimals or non-terminating recurring decimals. Or you can say the number in the form of P by Q, where P and Q belongs to integer. For example, 2 by 3, 3 1 by 4, 17 by 6, minus 2 by 3, 0, 1, etc. Okay, you can have a deeper understanding by just reading the book. So now let us see the properties of rational number. Okay, there are actually the rational number holds many properties, but there are main three properties that we have to learn today. The three properties are commutative, associative, distributive. There are some more properties. Let us say additive identity, additive inverse. These are the properties of integer as well. Okay, additive inverse and multiplicative inverse. These are the 5 properties that you must know in this lesson. Commutative property, associative property, distributive property, additive inverse and multiplicative inverse. I will write down a shortcut for you. Commutative property means there are of two types: multiplicative commutative property and addition commutative property for multiplication, commutative property for addition of rational numbers. So for addition, commutative property says a plus b is equal to b plus a, where a and b are rational numbers. Okay, multiplicative property, it is a multiplied by b is equal to b multiplied by a. These are the two commutative properties of rational number. We are going to see it in the exercise. Associative property. Associative property is again for addition and subtraction as well. Okay. For addition, the associative properties gives us that a plus b plus c. If we solve a plus b first, then it will be equal to a plus b plus c. That is the associative property for addition. If we have to add any three rational numbers, then if we add the first two rational number and then add the third, it will be equal to adding the last two rational number then adding the first. Also it is for multiplication, a multiplied by b multiplied by c. If I solve a plus b first, it will be equal to a multiplied by b multiplied by c if I solve b multiplied by c first. This property is called as associative property. Distributive property is addition and multiplication both taken at a time. It says that a multiplied by in bracket b plus c can be expanded as a multiplied by b plus b multiplied by c. We also call it a distributive law. See, in basic mathematics, I have covered all these properties: commutative, associative, distributive, additive inverse and multiplicative inverse. Okay, so now what is additive inverse of a rational number? I'm just giving you an idea. Additive inverse of any rational number is any other number which when added to a number gives some 0. That is, if there is a and if I add any other number b to it, the addition will become 0. So here b is additive inverse of a. सिंपल है, ज्यादा टेंशन मत लो. नोट, just change the sign. Okay, so here by just changing the sign we will get the additive inverse of any number. The additive inverse of 1 is -1, 2 is -2, 3 is -3, 0 is 0, 1 by 4 is -1 by 4, -2 by 3 is +2 by 3, -2 is 2. Just change the sign, you will get the additive inverse of that number. Now, what is multiplicative inverse of a number? Multiplicative inverse of a number is a number which when multiplied to that number will give you product 1. मतलब कुछ नहीं है, दो नंबर को अगर मल्टीप्लाई कर दे और उनका प्रोडक्ट 1 आ रहा है तो वो दो नंबर एक दूसरे के मल्टीप्लिकेटिव इनवर्स है. फॉर एग्जांपल, इफ आई राइट डाउन a multiplied by b, then if the product comes 1, then a and b are multiplicative inverse of each other. Inverse of each other. Here also b is additive inverse of a and a is also additive inverse of b. Let us take one example. Write down a note. just okay, here actually note is not to be written, just see it, ulta kar do, ulta kar do, just flip it. If there is 1, its additive inverse is, its multiplicative inverse is 1. If there is 1 by 2, its multiplicative inverse is 2 by 1. If it is 3 by 4, its multiplicative inverse is 4 by 3. If it is minus 1 by 2, multiplicative inverse is minus 2 by 1. Multiplicative inverse of 0 is not defined. If you multiply 0 by not defined, it will give you 1. No, it is actually not defined. So just flip it. Okay. So these are the properties. Now let us just go to the exercise and slam that. Okay. Read the question in the exercise. Okay. Don't look me rubbing the board. Okay. Read the question in the exercise. Exercise 1.1. NCERT page number 12. Exercise 1.1 I am solving. Exercise 1.1. Let it just solve the exercise. Question number 1. He says the name the properties under the multiplication used in each of the following. Okay, minus 4 by 5 into 1 is equal to 1 into minus 4 by 5 is equal to minus 4 by 5. Okay. Here the identity they have used, there are actually two identities used. These first two sum. Okay, if you just consider these two, they are saying that A multiplied by B is equal to B multiplied by A. That is commutative law of rational number. If we consider this A, if I consider it is 1, A multiplied by 1 is equal to A. This 1 is multiplicative identity. So there are two identities used here. First is commutative law, that is A into B is equal to B into A, and second is multiplicative identity, that is any number multiplied with 1 will give you the number itself. So 1 here is multiplicative identity. 1 here is called as multiplicative identity. If we multiply any number by 1, we get the number itself. So that is why 1 is called as multiplicative identity. Got this? Question number 1, okay? There are two answers for it. Commutative law of rational number as well as multiplicative identity. Okay, I will not solve it like this. I will solve in short spurts. So minus 13 by 7 into minus 2 by 7. Minus 13 by 7 into minus 2 by 7 is equal to minus 2 by 7 into minus 13 by 7. So here it is very much clear that A into B is equal to B into A. So this property is called as commutative property for multiplication of rational number. So simple. If it is A, it is B, then it is B into A. This property is called as commutative property, as we have already learned it. Next part, minus 19 by 29. Minus 19 by 29, which when multiplied by 29 by minus 19 will give you 1. So here minus 19 by 29, if it is A, then it will be 1 by A is equal to 1. So this property is called as multiplicative inverse. See, here A is just flipped. A is just flipped. Numerator become denominator, denominator become numerator. So A into 1 by A is equal to 1. This property is called as multiplicative inverse. A is multiplicative inverse of 1 by A. 1 by A is multiplicative inverse of A. So got this? Question number 1 is done for exercise 1.1. I think so someone wants to come in. So late. It's blur. Okay. Yeah. The video has become blur. Yeah, I think so now it's okay. Okay, let me explain it again. Here minus 13 by 7 is A, minus 2 by 7 is B. So here it will be B into A. A into B is equal to B into A will be commutative property. And here, if I suppose minus 19 by 29 is A and 29 by minus 19 is, then it will become 1 by A. So A is multiplicative inverse of 1 by A and 1 by A is multiplicative inverse of A. So here multiplicative inverse property is used. It is not blur, na? Okay, next question. Tell what property allows you to compute 1 by 3 into 6 into 4 by 3, 1 by 3 into 6 into 4 by 3, okay, 6 into 4 by 3 is equal to as 1 by 3 as 1 by 3 into 6 into 4 by 3. Okay, let us first commute these, okay, whether this is right or wrong. If I solve it like this, it will be 1 by 3 multiplied by 24 by 3, correct? So it will be 8 3 are 24, so it will be 8 by 3. And if I solve it, it is 6 by 3, that is 2, 2 into 4 by 3, it will again become 8 by 3. So yeah, both are true. If I consider it A multiplied by B multiplied by C, then it will be A multiplied by B multiplied by C. And these two terms are equal because here we have used the associative property for multiplication. Associative property for multiplication of rational numbers. Associative property for multiplication of rational numbers. Done? Let us take question number 3. The product of two rational numbers is always a. The product of two rational numbers is always. The product of two rational numbers is always. Okay, let us try to identify the product of two rational numbers. Product of two rational numbers. Let us take in two different type of rational numbers. First, I will take into decimal 2.3 multiplied by 3.2. Let us check the product. I will do 23 into 32. So it will be 3 to the 6, 2 to the 4, 3 3 the 9, 3 to the 6, 6, 13, 7. So it will be 7.36. If I take a rational number and multiply it with rational number, I am getting a rational number. Now let us check in the fraction form. If I take any rational number 2 by 3 and multiply it by any other rational number 4 by 6, 4 by 8 let us take, 4 by 9 let us take, then it will be 4 to the 8, 9 3 the 27. Again it is a rational number because it is in the form of p by q, where q is not equal to 0. If I take a decimal and a rational number 2.3, if I multiply it by 2 by 3, what will I get? I will first multiply by 2, it will become 4.6 by 3. I will get answer 3 1s are 3, point 3 5s are 15, 1 3 3s are 9, 3 3 3 3 3 recurring, that is 1.53 recurring. Yeah, it is a rational number. Non-terminating, repeating, so it is a rational number. So whenever we multiply two rational numbers, we will get a rational number. So the product of two rational number is always a rational number. Okay, so answer is the product of two rational numbers, the product of two rational numbers is always a rational number. That is Q, rational numbers. Okay, so I think so the exercise of the rational number is finished. There is no other exercise in the rational number, correct? There is only one exercise, I think so, in the rational number for your syllabus. Is there any other exercise? No, we do have only 1.1 exercise. So we are directly going to start the next chapter. Let me pause this. So this is the end of our video for rational number. Okay, directly I have uploaded the next chapter, that is linear equation in one variable. Okay, so I am going to start directly linear equation with one variable. Just look at that video. Thank you.